it received great support and participation. ETSI, TM Forum, GSMA, ITO, 5GAA, and over around a dozen organizations participated in our first session of GIO Roundtable, and people felt they benefited a lot from the roundtable. In addition, since this is an open platform for equal participation, more and more organizations proactively participated in this platform. And it's not just the 12th session of GIO Roundtable. More importantly, in the past 3 years, despite the COVID-19 pandemic, we're still able to hold 2 sessions per year online, and we have reaped great achievements. And through the GIO Roundtable, more and more industry organizations participated in it. They are from the manufacturing, healthcare, finance, and other different sectors. More importantly, on this platform, we have released many digital transformation white papers. And very importantly, it has helped to foster the communication dialogues between different industry organizations for them to know about their respective industries and how ICT was able to enable these sectors. In addition, during digitalization, we hope that this platform could be able to connect us to help us better coordinate with each other in this digital world. As you know, this roundtable spans across sectors, countries, and industries. And it is because that this is an equal platform where we have thorough and sufficient communication. It received great support and participation. As the founder and the chair, I would like to express my heartfelt thanks to all of your participation, and I would like to congratulate on the achievements we have made in the 12 sessions so far. We see great challenges in the current world, including AI governance, how AI is able to accelerate, enable digitalization in the industry, smart manufacturing, blockchain, Web 3.0, all of these different sectors still face very many challenges that requires to communication and to communicate and coordinate with each other. So we hope that we can maintain the frequency of having 2 sessions per year for our GIO Roundtable. And as we walk out of the pandemic, we are able to have face-to-face discussions, even though we have sub-venues. It is because some of our industry organization participants are having face-to-face meetings in Europe, and they are now joining us online. And after the pandemic, I would say this is the online GIO Roundtable with the biggest scale, as no one is wearing masks today, and it means that we have forgotten about the troubles and challenges posed by the pandemic in the past 3 years. And looking ahead into the future, the GIO Roundtable will play a more important role. And at this occasion, I'd like to express our gratitude to all of our industry members. Because for the past 12 sessions of GIO Roundtable, a lot of work has been done, especially our administration team, our staff. You have overcome a lot of challenges to continuously provide communication and support for others. And I believe this platform will become even stronger and will receive support from even more organizations and experts. We hope that this roundtable could be a great success in Shanghai, and we also hope that our sub-venue in Europe and our colleagues, friends joining online could also reap great benefits from that. We would like to warmly wish this roundtable a great success. Thank you very much.
Many thanks for your kind and inspiring words and opening to more participants in the future to let the roundtable grow. And we also have Tim Benham, CCO and Executive Vice President of the TM Forum as co-chair of today's 12th GIO Roundtable. Let us visit Tim. Can you? Yeah?
Yes.
Let us visit Tim for his speech.
Thank you. Dear William, dear distinguished guests and fellow delegates, my name is Tim Banham. Ni hao, good morning and good afternoon. I'm Chief Commercial Officer and Executive Vice President for TM Forum, and honored today to be co-hosting this very important event along with William, and very pleased to be representing TM Forum as a fellow industry body driving this change in the industry. And as one of the startup organizations and founding members of the GIO, we're really pleased to see how it's evolved over the last 6 years. We have had 12 conferences, and we are honored to be an active participant throughout that process. We have a number of new colleagues joining us today, the new faces that we've seen, and again, we welcome those from TM Forum as well. It's clear that over the last 6 years, there's been a lot of change that we've been supportive of driving. We have been not just participating in these roundtables, we've also had many separate seminars on important topics like autonomous networks, and we see the leading industry bodies joining forces to make sure that we continue to cooperate and drive the change that we've seen in recent times. This is the second time that TM Forum co-hosted this event, and during the last roundtable 4 years ago, we launched the collaborative white paper on industry digital transformation architecture exchange. This focused session today is all about artificial intelligence, which as we are in Copenhagen at Digital Transformation World Ignite, we have seen many sessions on the topic of AI and actually seeing how it's driving real change in the industry. It's really important that we share those experiences and that we work together to continue to drive the evolution of this industry, leveraging the important technologies around AI. TM Forum has built lots of assets in this area and all around how we can enable network automation, intelligence, and how we can enable those vertical industries that are so important to the growth of this connectivity industry. My colleague and Asia Program Director Kevin Zhu is here with me today, and he'll be sharing more information with you in the sessions later on. I wish this roundtable a tremendous success and look forward to seeing how this important topic evolves over the coming months and years. Thank you very much.
Thank you very much, Tim, for your inspiring great greeting notes. Now, having opened this GIO 12 roundtable, let us have a look and review the agenda. We have 2 topics that we will discuss. The agenda is in front of on your table and also on the screens. We have 2 slots. Slot 1, AI application standardization and progress in different industries, followed by an open session on discussion. And slot 2, building a safe and trustworthy AI industry environment. And again, a slot for discussion. And please leave your questions for the discussion forum to be sensitive in the time. So we appreciate your time awareness to keep the slots given in the agenda. So let's give the floor to the first presenter from Wen Zhao from ITZIA.
Dear experts, ladies and gentlemen, good morning, good afternoon. I'm very pleased to be invited by GIO to share with you our observations on the role of AI to drive the digital economy, as well as some of the actions we have taken. I'm from Penchen Laboratory. My name is Gao Wen. As the agenda mentions, I also work in ARTISA. ARTISA stands for AI Technology Industry Standard Association. It specializes in developing technical standards for artificial intelligence. Penchen Lab is a very young organization with a short history of 3 years. The mission of the laboratory is to develop broadband communications, new networks, and large-scale application of artificial intelligence. We undertake a lot of research projects in broadband communications, new networks, and large-scale applications of AI. So we work in these three areas. In broadband communications, our vision is to enable barrier-free communication. In terms of the new network, our vision is to create limitless connectivity. And in terms of the large-scale application of AI, our vision is to propel endless evolution. In these three areas, we have deployed some resources and we have developed some research projects. We have also some underlying algorithm and the technology support. We have connected the hardware system, and in the middle layer, we have the software and system, including some basic software and applied systems deployment. In the past 3 years, we have already done some work in the large-scale application of AI. Computing power is critical to economic growth models. In the past, we think computing power is critical to the digital economic growth, and now it is related to the broader economic growth. Tsinghua University and IDC developed a global computing index assessment report. With 1% increase in the computing power, it will contribute to 0.35% increase in the digital economy and 0.18% of the GDP growth. And according to their assessment, the computing power is positively correlated with GDP or digital economic growth. The comprehensive computing power of US ranks the first and comes after China and comes the second. And France and Japan comes after China. So it correlates with the size of economy because USA is the #1 economy in the world, while China is the second. So computing power is very critical to the economic growth of a country. We couldn't imagine that a very strong country has a very small computing power. So for a country to enjoy rapid economic growth, we should deploy a lot of resources in developing computing power. China ranks #2 in the computer power next to the US. However, the computing power of China has enjoyed a very rapid growth over the past few years. The average growth rate of computing power of China is around 13.5%, more than 10%, and higher than the speed of other countries. Correspondingly, it means that China's economic growth is faster than other countries. So we believe that the computing power will be a very important basis for the future economic and social development. So we believe that it is important to connect the computing power like a grid, a power grid. and people can have access to this power grid or the network of computing power. Of course, such grid will first serve the government organizations and enterprises, but eventually individuals will have access to the network of computing power. And such network of computing power will be a critical infrastructure. With this vision in mind, the Chinese government has invested very heavily in the power grid network. For example, China has a east to west, a west to east power transmission project to transmit the electric power from the west to east of China. Because the west part of China has a lot of resources like the solar power, while the east of China is very populous and enjoys fast economic growth. If we build a lot of power plants in east part of China, it actually will have a very high cost and cause a lot of pollution. That's why the Chinese government implemented a project called West to East Power Transmission Project, and it is cost effective. So based on the success of this project, the Chinese government is also working on another project called East Data West Computing. The digital economy is thriving in the East, and there is a huge need for computing power. But if all the computing power is deployed in the East, it entails a huge cost and will cause huge pollution. That's why the government is planning to move computing power to the West. So this is called East Data West Computing Project. We have seen major progress in this project in 2023. We call this is the starting year of East Data West Computing Project. Of course, we are only in the early stages of the project. A lot of things we are waiting to be done. And a lot of technologies need to be developed. Of course, we should take one step ahead. We have to think of all the potential challenges that we are going to meet. So our lab is proposing the development of China Computing Net, which is abbreviated as the C2Net, C-square net. We envision this China Computing Net to be a power grid, and we will operate this computing network like the internet, and people will have easy access to the computing network just like they have easy access to the power grid. Of course, you have to get yourself ready for a lot of technical challenges. First challenge is the communication challenges. We know that there is a long distance, about 3,000 to 5,000 kilometers between the east and west of China. And the latency will present challenges to the East Data West Computing. And we don't have enough broadband width, so we will have these double challenges. We are proposing to achieve a 1 millisecond latency per 300 kilometers, which is an improvement on the 1 millisecond per 200 kilometers. And so we have to use the optical network and probably in a vacuum environment. So it will help us to achieve the target of 1 millisecond latency per 300 kilometers. Another challenge is the capacity of the broadband width. The current standard is around 400G, and or 800G. In the future, can we improve that to 1T, 10T, 100T, or even 1000T, which is equivalent to 1P? These are the challenges of communication. Of course, another challenge comes from the computing power scheduling. We have different types of computing power: cloud computing, intelligent computing, and supercomputing. They have different uses. The size of the data they use are different. And the computing density is also different. So we have different solutions for these different types of computing. So is it that we can develop a uniform package to combine or integrate these different types of computing in terms of the architecture, charging modes, and etc. So we can have a uniform scheduling for these different types of computing powers. This is another area of challenge. That's why we have to solve these problems technically. For communication challenge, our proposal is to build a direct-to-connect ultra-broadband optical network. It will help to lower the latency to the level of that in optical network or in a vacuum environment. To rise to the challenge of computing power scheduling, we need to build a cloud-native network to organize and schedule the computing power. Why cloud-native networks? The current network is based on the connections. If we make the cloud as the core, we believe that the organization architecture should be different. So we should enable this through the cloud-native networks. We have the core cloud, but we have a number of edge clouds. And the edge is connected by the connection networks. And we also have a connection between the edge clouds and the core cloud. We can have uniform organization. We need to connect these access networks and service networks, and we will set them through the edge cloud. And we will develop the cyber twins to enable the mobility and security. Of course, we need to develop the guidelines for the cloud-native networks, including some open source container system, operation systems, and cyber twins. These are the basic architecture for the cloud-native networks, and we should provide guidelines for them. Of course, security is of critical importance. If we set up a cloud-native networks, we can set up some immunity-like security mechanisms to avoid some attacks or hacks like internet. Our overarching goals are as follows. We hope to develop new architectures where users can access the computing powers according to their needs. We have done some initial work in computing power. We have a 1000P intelligent computing system using Shenzhen 910 chips of Huawei. The system was completed 3 years ago. We're working on the next machine called Cloud Brain 3. And the computing power is the 16 folds that of the existing computing power of the machine. If we complete this machine, it will provide a strong support for the training of a foundation model. It is being included in the C²NET phase 1. We have a small trial project called C²NET 0.1. It was supported by National Development and Reform Commission. We started research in 2019, and the project passed the acceptance test in June 2022. We have gathered more than 20 heterogeneous computing clusters. And the aggregated computing power exceeds 3 EFP16 operations. We use both chips from Capricorn, Huawei, and NVIDIA. So we set up this mixed computing power architecture. Apart from that, we have also worked on the standardization, because if you want to bring together these heterogeneous computing powers, we have to unify different standards. That's why for this purpose, we developed this standards. And thanks to the support and the leadership of William Xu, we now have verified key technologies of long distance, 220 kilometers, high throughput or optical MEMS. We can promoting high throughput interconnection. It has been very successful, and it is ready for mass industrialization. We are also working on the phase 1 plan for C²NET to enable different applications. And we will seek new progress in the direct connect optical network. With this completed, we will be able to establish this East data, West computing. So we will schedule resources across different regions, and the computing powers will be used or accessed through different regions. So to sum up, computing power is the productivity, or holds the key to the productivity of the big data era. In order to drive the digital economy, the computing power should be easily accessible, and we need to develop network to connect to these computing power.
Many thanks, Wen Gao, for this brilliant timing and excellent overview on how computing power will accelerate the growth and is related to the economic growth, and also for the outlook you gave on the potential solution of cloud-based or solutions of power, of computing power. Thank you very much. And so now I'd like to invite Chuck Byers from the IIC to give his presentation, and we will change the slides for you, Chuck. You just say next slide and we will do it for you, and then we can start the presentation whenever you are.
Hello, good morning, good afternoon. Thank you so much to the GIO Roundtable for inviting us. And on behalf of the Industry IoT Consortium and the Object Management Group, I'm happy to talk to you for about the next 20 minutes about industrial and manufacturing applications of AI. Next slide, please. Topics today are a little bit about the different types of AI that might be used in manufacturing applications, some examples of those applications in real-world manufacturing settings. We will then discuss the trustworthiness of AI briefly and several attributes of that, and something about the social impacts of AI. Next slide, please. The Object Management Group is a set of consortia and standards bodies that are very interested in trustworthiness, digital transformation, the application of the Internet of Things, and the application of advanced technologies like robotics and artificial intelligence to real-world problems. We invite you to visit our websites and join us as we attempt to move forward these important technologies. Next slide, please. Artificial intelligence really has a deep impact on productivity, efficiency, agility, safety, environmental impact, and labor aspects of factories. Some of these impacts are good, some of them are bad, and we'll talk through that. We can really, in many cases, supplement or sometimes replace certain types of human labor with certain types of artificial thought. We think that factories that fail to apply AI are at the disadvantage to those factories who succeed in applying AI. And it's really only as good as the data that's used to make the models and to feed the inference engines that are connecting all of these AI devices to the industrial systems, sensors, and actuators that are involved. Next slide, please. There are several different types of artificial intelligence, and these are well beyond the generative and large language model AIs like ChatGPT and others that you may have heard quite a lot about recently. Some of these involve simple heuristics like rules in expert systems. There are recommendation systems that tell you sort of what to do next. There are machine learning and deep learning systems, typically using neural network technologies to infer what some system might be doing. We use a lot of natural language processing. That's text to speech, speech to text, various kinds of pattern recognition from human languages. Machine vision is enormously important in manufacturing technologies, using cameras to emulate the human visual systems and artificial intelligence to determine what the images coming off of those cameras mean and what are the implications of those meanings to the systems. Robotics is another type of artificial intelligence where we're really trying to build reflexes and we're trying to build coordination of muscles equivalent in electric motors and digital control systems. As I mentioned, generative and large language model artificial intelligence is the place where lots of interest is being set right now. And it is really related to creating original outputs. Almost creativity and strategic thinking can be applied there. This is representing an emulation of higher level brain functions, not just reflexes, but cognition. And that is hugely exciting and billions, perhaps $1 trillion worth of economic impact from those technologies. Finally, something that isn't exactly here yet, but coming soon, is what we call explainable AI. The models in explainable AI are not just black boxes that you have no idea what's in them. They are actually things that humans can go backwards and follow the AI reasoning, inference, model building to the original data that created that model. That's a way that you can improve the trustworthiness of manufacturing systems. Next slide, please. Now we will go into 3 different manufacturing scenarios, and I will illustrate the applications of AI in each of those scenarios. What we see on these 3 slides are a half a dozen or a dozen little bubbles. These represent pointers to certain portions of those industrial processes. Then each of the bullet items, and I use 3 examples for each of them, represent places where artificial intelligence could be applied or is being applied to those processes. The first example is a manufacturing plant that is manufacturing wind turbines for electric power generation. So these have several different elements to them. Raw material and subassembly comes in. We mold fiberglass blades, perhaps 20 to 40 meters long. We have a device called a nacelle, which includes the generators and transmission systems. We have a hub, which is the thing that holds the blades to the nacelles. All of these are manufactured in different zones at the factory. And Question? Okay. Some examples of, I'll just go into a couple of illustrative examples in each of these. So for example, in blade production, those robots that are laying the fiberglass and applying the resin have diagnostics and troubleshooting. So they can determine, for example, if a nozzle is plugged or if a motor is jammed. And they use neural networks and recommendation engines to determine how to fix that problem. We also do continuous process monitoring, probably using machine vision. And we use cycle time reduction, perhaps using recommendation engines or some sort of a large language model creative solution. If we take a look over in the engineering part of the factory, we might be using large language models to customize individual products. So changing, for example, the shape of airflows going across these turbines in different settings depending upon the expected wind conditions. We could also generate code. So many of these wind turbines have significant amounts of software in it, and generative AI is capable of generating usable Python code and other types of software. Finally, we might even do the documentation creation. So language, different languages, different sets of users manuals, maintenance guides, and so forth could be done. You can study all the other ones in detail, and there's a list at the end of these types of AI solutions. Next slide, please. The second manufacturing scenario that I'd like to talk about is something familiar to all of us, the creation of soft drinks. In this case, we are bottling cherry soft drink beverages. What we have in this assembly line is a number of raw material entries, including the plastic that we mold the bottles out of. Then we have a set of industrial processes where we, for example, mix the beverage ingredients to create the finished liquid product. And some of the process chemistry involved in that might involve monitoring the sensors. And you can see the little orange circles represent all the different sensors that may be applicable here. We might, for example, monitor pH or pressures or colors of the liquids flowing through that beverage mixing system. We may have an adaptive AI that is controlling that. So for example, if the incoming water is a little hotter or colder, we may adjust the carbonation or the mixing times based on the differences of the material entries. Finally, we might do safety. We may have sensors and monitors that are determining, for example, if the pressure is too high or if bacterial contamination is detected in the mixing stage. We might also take a look at some of the things that are happening in the warehouse. So when we get done with the bottle filling at high speed, capping, labeling, case packaging, we get to the warehouse. And we may have, for example, in that warehouse, artificial intelligence using large language model and generative AI to help us optimize the inventories. We might have autonomous vehicles that are using robotic and machine vision technologies. We might also have humans working alongside of all this automation in that warehouse. And we may use machine vision to verify that they are wearing their personal protective equipment correctly, if they are required to wear a hard hat or a sling, for example. So those are some examples in beverage bottling. Next slide, please. You'll see in this example, not exactly a manufacturing process, more of a logistics process after these products are manufactured. This particular system uses drones to deliver products to various endpoints. And we have the drones that are flying around. We have a number of warehouses, robotic mailboxes, landing pads, where those drones are taking the product from the mailbox and putting them into industrial and consumer output hands. Some examples of AI in this very complex system could include, in the robotic mailbox, we actually have control of perhaps up to a dozen robotic actuators to load and unload the drones with their packages automatically. We might have machine vision to verify the identification using biometrics of the user who seeks to receive his or her package off of this robotic mailbox. And we may have storage optimization, where we're using generative AI to determine which of the many package lockers should be used for which of the expected packages that are rolling through that particular robotic mailbox. In the central cloud, we may be looking at air traffic control kinds of functions, where we are predicting collision based on neural networks and the flow of various aircraft in the airspace. We may manage the priority of this product as being a high priority medical delivery, where this one is a toy. We may have artificial intelligence helping us optimize the fleet for that. And finally, we can optimize the efficiency. We can reduce the amount of miles that each of these aircraft are flying based upon the expected loads on that network. And of course, the drones themselves are autonomous. There's no pilots in this kind of system, and they use layers of artificial intelligence and machine vision and generative AI in order to safely and efficiently control the flights of those drones. So altogether, we've sort of seen wind turbines that generate the energy to run these systems, fast-moving consumer goods manufacturing as beverage bottling, and a logistics system. We can see that AI is really helping the entire raw materials to satisfied consumer aspect of manufacturing. And that's only going to grow more important as these systems become more mature. Next slide, please. What I've done is summarized some of the sorts of AI applications that you might find in each of these different types of AI: expert systems, machine learning, machine vision, robotics, and generative. And you can actually look in there and see some of the ways that you might use this in manufacturing settings that might be familiar to you or important to your company. This list is only a partial list, of course. There's lots and lots of opportunities being developed every day for artificial intelligence in these important sectors. Next slide, please. Trustworthiness is very important. As we start to use artificial intelligence to become a more central part of our manufacturing environment, we want to make certain that this system is trustworthy. The Industry IoT Consortium has defined multiple aspects of trustworthiness, and they all apply to artificial intelligence. So the first one is security, especially cybersecurity and physical security. Artificial intelligence, machine learning, machine vision, and generative AI are really excellent at discovering threats and determining countermeasures to those threats. Second, we have privacy, certainly very important in the European Union, in the state of California, for example, and elsewhere in the world. But this artificial intelligence techniques can help us anonymize personally identifiable information, secure medical records, and so forth. Safety is a very important consideration. I already mentioned monitoring personal protective equipment. We can detect dangerous situations, for example, excessive pressure in a petroleum refinery. We can detect various kinds of potential accidents, like an autonomous vehicle about to run into something. That's all artificial intelligence functions, and it represents a life-critical aspect of using artificial intelligence for industrial purposes. Reliability is very important in these cases. So can we detect impending failures, and can we route around problems? The previous speaker mentioned a very exciting network deployment in China. What happens if one of those fiber optic cables through an accident is cut? Maybe somebody in an excavation backhoe chewed that cable up. Artificial intelligence can help us reroute the traffic around that to create network reliability. Resilience is similar to reliability, but it's really more about expected situations. So for example, what happens if a data link is overloaded, if a processor's out of memory space? Those kinds of questions need to be managed. And artificial intelligence is a way that the software underlying these sophisticated networks is able to anticipate and react to those kinds of situations before any problem causes production shutdown or quality degradation. And finally, there's this question of accuracy and quality. We can improve the precision, repeatability, and quality of industrial processes through the application of AI technologies, especially neural networks, machine learning, and generative AI techniques. So overall, artificial intelligence helps us to make manufacturing more responsible, and as a result, more economically viable, more environmentally friendly, and more apt to satisfy the end customer of the industrial goods. Next slide, please. As I mentioned at the beginning, not all artificial intelligence is necessarily a positive impact. And much has been said about the potential negative impacts of artificial intelligence. And here's some of them. Artificial intelligence inference engines occasionally use bad models, which are built upon bad data and algorithms. And this can cause bias or hallucination or various kinds of data accuracy questions. Explainable AI can help us reduce the root causes of some of those things. Models are not transparent. We can't really understand them as humans. And once again, explainable AI and careful testing of these systems is important. The intellectual property rights and copyright issues are all large importance. So if the artificial intelligence models are built off of millions of copywritten documents, how do the owners of those copyrights receive fair compensation for their contribution to the goodness of those artificial intelligence models? We're still working on that problem. Labor impact is a gigantic problem across the world. Artificial intelligence is potentially going to start replacing many types of blue-collar labor and some types of white-collar labor. For example, lawyers and diagnostic doctors may start to see artificial intelligence replacing some of their capabilities in a decade or so. What is that impact on labor, and what do all of those people who are displaced do? Fortunately, in previous industrial revolutions, and there's been 4 or 5 of them, we have seen that the human labor that's displaced by the advancement in industrial technologies tends to go on to more technical fields and tends to build the next level of industrial automation. So I'm not terribly concerned that the globe is going to lose 1 billion paying jobs as a result of artificial intelligence. I think it might make 1.5 billion paying jobs as a result of the new opportunities created by artificial intelligence. Education and training is a certain important problem here. You have to make certain that the human race remains educated and doesn't turn, for lack of a better word, lazy because artificial intelligence is doing things for them. Certainly a large concern among college professors because generative AI can write excellent term papers. Humans are still necessary to generate prompts and to edit the results and to fact check the AI to make sure it's not hallucinating. But there are certain concerns about how this goes in education. Power consumption is also a very large concern for AI. I recently completed a study that shows the GTP 3.5 model, which is underlying the ChatGTP system that we have heard quite a lot about. It requires around 400 megawatt hours of electricity for a single training run. It takes 3.5 years or so on the largest NVIDIA DGX H100 GPU systems. So that is a significantly important concern that we may have to build dozens or hundreds of gigawatt electric facilities. I hope they're renewable, wind, solar, water power, or maybe small modular nuclear reactors, and not burning fossil fuels. If we burn fossil fuels to run this AI-based economy, we're going to have serious problems. We may have some concerns about the erosion of the cognitive skills of people. Are people becoming less likely to solve problems because their brains have gotten used to artificial intelligence solving problems for them? Many ethics problems associated with artificial intelligence. There are concerns, for example, how does it determine who to save if there are 2 bad outcomes to an industrial accident? Those kinds of questions mean that the AI has to make what amount to ethical decisions, and so far no humans trust AIs to do that. Finally, there might be monopoly power players. Certain industries, certain consortia, certain governments might get very powerful very quickly as a result of their use of AI, and that potentially isn't the best thing for the planet. The conclusion here is that most experts agree some form of what we call guardrails are necessary. Government or industry self-regulation is important in order to pull all of these concerns into control. Next slide, please. The Industry IoT Consortium and the Object Management Group have several projects running right now on various forms of AI. The Responsible Computing Initiative is in the midst of doing a white paper, how to tame this powerful generative AI technology, and you can see some of the topics there. This will be published in October in the IIC Journal of Innovation, so please look forward to that. We also produced a webinar whose URL is there, and you can receive that on YouTube. Very interesting about the potential impacts, positive and negative, of generative AI. Next slide, please. A second part of the object management group beyond responsible computing is where I serve as CTO, the Industry IoT Consortium. And the Industry IoT Consortium is, I'll move forward to the next slide, please. We're working on an artificial intelligence framework document that has been published. You can see its URL there. And we are working on an industrial AI white paper, which will go through many of the topics that I have shown you some advanced knowledge of in today's talk. You can see some of the things that the industrial AI white paper will do and some of the topics that the Industry IoT Consortium's Industrial AI Task Group is working on. The final part of the object management group that we might want to discuss AI is shown on the next slide. If you could advance, please. This is the standards development organization of the object management group. And the standards development organization is really interested in taking artificial intelligence and making it adaptable to various kinds of standardized environments. If we could go forward to the next slide, please. Thank you. We see here a data sheet. There's a URL there for a data sheet and also a standards white paper that the Object Management Group Standards Development Organization has produced relating to artificial intelligence. We are also working right now on various modeling and copyright issues. We've got various observability standards to make AI more trustworthy and more predictable and explainable. And we're also working with several standards bodies, including the IEEE, in order to pull together a standardization landscape for artificial intelligence. Next slide, please. My conclusions are that AI in its various forms is very important to the future of manufacturing and industrial technologies. We think that we can improve quality, productivity, cost, efficiency, safety, and many other aspects through the careful use of artificial intelligence. As we've seen in my 3 examples, there are thousands of examples. AI is potentially usable in all different corners of many different types of manufacturing plants. And manufacturers need to consider carefully where AI should be employed in their processes. The trustworthiness of AI systems, including impacts of security, privacy, safety, reliability, resiliency, and accuracy, really needs to be considered at all stages, from the requirements through the architecture, implementation, deployment, and ongoing management of artificial intelligence systems. Not all impacts of AI are positive. We need to worry about things like labor bias and energy consumption of these AI systems. We believe that some guardrails are useful. I don't know if they necessarily need to be government mandates. They could be opportunities for organizations like ours and the people represented around our tables, physical and virtual today, to jump in and make important policy recommendations for the way that these AI systems will eventually be deployed and ubiquitous across manufacturing environments. That's my talk. Thank you so much for listening, and I look forward to the rest of the conference. Thanks on behalf of the Object Management Group.
Thank you very much, Chuck, for this excellent insight given on the different AI types. We've seen the different scenarios of manufacturing, and your outlook you gave on the generative AI and the focus on trustworthiness and also making AI responsible. Thank you very much. Now, let's give the floor to Shinpei from the Autoware Foundation. Shinpei Kato.
Thank you, 谢谢。大家好,
Good morning, good afternoon.
my name is Shinpei Kato. I represent the chairman of the Autoware Foundation, which is open source organization for autonomous driving. So today, it's my honor to share intelligence with people. So my position is that I represent the chairman of Autoware Foundation. At the same time, I also own my startup, and I also work for the University of Tokyo as an associate professor in computer science. So autonomous driving actually means a lot. But if you look at from hardware prospect, left-hand side, it is getting more and more simplified because AI is getting more mature. So you don't need a lot of computers. Now, one single computer can accommodate very sophisticated AI, while you still need some traditional electrical and electronic systems like a vehicle computing unit, braking, steering, or motor controller unit. Right-hand side, it's building blocks of software. They're also getting more and more simplified. And you can imagine that each box displaying a slide is kind of individual functions of autonomous driving, starting from sensing, and it needs to localize the vehicle, and it wants to percept what's going on and makes planning and control the vehicle. AI technology is used in the whole pieces of boxes with kind of different manners. And what is quite important for the software prospect is that it's getting more and more open source oriented. Before I step into kind of details of autonomous driving, let me introduce why open source is important. So people often say that how you can make monetization on top of open source. This is one example from a startup company that I founded a few years ago, which is called T4. Open source is something that you can imagine it's halfway through in case that you climb the mountain. It never goes to the summit, but it helps you to go to the fifth station without spending any resources. Now you may want to have some platform on top of it, which could be also supporting several solutions that actually address the pain points of the customers. Imagine that customer deals still need some effort, but using open source and platform is something that you only build once. But sometimes solutions you have to build every time to satisfy the customer's requirements. But these, say, layered strategy will help people to be able to join in the market of autonomous driving because you don't have to build the system from scratch. You can leverage open source and platform. Now, this video visualizes how autonomous driving software recognizes the real world, which is given by open source. You can get these functions without writing any single line of source code. You can just download the software and click the buttons a couple of times, and you get this level of autonomous driving software even today. It can recognize the objects in 3D environments, and it can also make a planning, generate the trajectories, how the vehicle should move. This intersection example is a very good actual use case to see how AI is significant. AI capability is actually much beyond the human beings in terms of perception. It can recognize these whole objects, including the locations and angles, motions, in a very precise manner. But behavior or planning, still AI has some room for improvement as human beings can break a rule. AI, one of the challenges is that it cannot break a rule. So which needs to be aligned with how can society also accepts AI, because people believe that AI will not break the rule. But in fact, human beings often break the rule in order to make optimization of the behavior. And people may think that, okay, so open source software is already a standard level of autonomous driving, but it's not actually true, because in order to make AI or autonomous driving to be deployed in the real world, you have to satisfy a lot of requirements. For example, cloud native environments now enable you to have different types of server systems in the cloud. This just shows 3 examples, but there are actually many